Here we have electric pulse disaggregator Spark-2 M. It's specially produced for Gemfield's PLC. It is due to the fact that we came here all the way from Russia to set it up. Now we have to harmonize all operations for the specific use for emeralds. Oleg will show now how to operate the whole installation, so it will then be possible to show it to all colleagues from Gemfields. Okay, say hello, Oleg. Alright, so there are several devices that are in operation altogether. So basically, first of all, the electrical part, which is provided by the control panel, by the main panel that's delivering 380 volts to our power supply, which is here. And it's also the whole device controlled by the power box down there. So you mind there are signs of electrical there, so you have to be aware of this. Also, from outside the cage we see the dielectric rod. It should be specially rated, so this one is not of use. It's just to show that there must be a dielectric rod where the operator stands and while operating the device. Whenever the electrician switches on the power here, the operator, under the supervision of the same officer, can continue the work. It must be two people, presumably the electrician and the operator, who will operate the whole device. Not less than two, can be more. Those who will be working on that here should really be authorized by the electrician. The electrician has to be authorized by the authorities. I hope that will be done by electrical inspector on site. So, alright, so whenever the power is on, we can start on doing basically the tests, or we can start processing by electric pulse disaggregation. So one has to switch power on the main box. So here is the key that is always with an electrician, local electrician on site, who can switch on the whole power to the device. Inside you can have another thing. Electrician will open it and switch on the power to the main power switch to the actual device. Then he closes that, takes the key out, basically pulls his own key and switch the whole thing in. Alright, so whenever the whole thing has been energized, you can start using the device. So here is the button that means on. Whenever it is on, the power here is also on, so you can switch here the power supply. It's high voltage power supply delivering 50 kilovolts to the whole DC, to the whole AC, 50 AC to the whole installation. You will see the numbers here. Then you will operate simply by this regulator, whatever, so to increase the voltage. Here you will see the voltage rating, and then whenever it attains 50 kilovolts, you can start processing by pushing this button alone, which means the whole feed from here comes to the capacitors. Now Oleg will open the door and show you what is inside. By the way, you see here the window through which you can monitor the whole operation while it's working. So we go inside. What we see here several devices. The first device, high voltage power supply, that's facing his controls out, and also it has got its part at the back, which has got separate wires. One is electrical supply, which is attached to the circuit. Another one is grounding, which goes all the way from the special high voltage rated wire down to the grounding strap, or down to the grounding point. Everything should be grounded at one specific spot. Then you have the high voltage wire that goes all along through here. These are special precautions because we have to defend this power supply from the back current, which sometimes happen because the electricity doesn't travel only from positive to negative electrode, but also can go backwards. This supposedly be heated because these are, what are these?
Resistors. resistors.
Okay, these are special high voltage resistors. That's
1.5 kilo ohms.
1.5 kilo ohms, which means that they will get hot eventually. Also, the other bit of the equipment is this active bleeder. So whenever the system is on, whenever the power is on, whenever you switch on this power supply and you energize the whole installation, the power supply stands so that the shelf is supporting it from below, but this piece is very sharp, so one who should be very careful whenever operating inside, not to cut his own skin or the hair, because it's pretty low. Here is the magnet that activates the system. So whenever it's closed, the door is closed, you can energize the system. Basically, whenever the door is open, this de-energizes the system, and this rod drops down by gravity and eventually discharging all the capacitors that were charged or residual charge you have there is in them. It's all discharged to ground. So as I said, all the parts of the equipment has been grounded at one spot, so you can see all the straps going all along the cage. Basically, the cage itself is very well grounded at one spot, and that assures that basically whenever anything happens to the system, it all gets leaked to the ground. The old energy will get leaked to the ground. So here you see the bank of capacitors. Bank of capacitors consists of 5 different stages. It's called Marx generator, 5-stage Marx generator. It's equipped with special coils on both sides, from one side and from the other side. So it's pretty much a delay for discharge of these capacitors. The capacitors are connected in parallel but discharging in series. So this series has been led one by another conductors on the top. In the end, eventually the whole energy which is stored in these capacitors will get discharged through the electrode here and into the chamber here. So this stand for the electrode specially made, so whenever you not using the electrode, it should stand there. The whole thing is covered by rubber, though it's not very important, but just in case any leakage of any energy to the floor, because everything from the floor to the ceiling is made of metal, though it's grounded. We just want to make sure that there are no any side effects to actual operation. So as I said, the discharging rod, or how we call it?
Active bleeder.
Okay, active bleeder. It's one defense system for the whole installation and for the operator. So whenever any failure happens to the installation, whether it's with the power supply or with the capacitor or with anything else that basically interferes with the load, this guy will drop down and de-energize the whole installation. On the other hand, there is another way of de-energizing the capacitors manually by this rod. It's rated how much? 110 to 200 kilovolts, which means that you can easily discharge one by one these capacitors, simply because every stage is not more than 60 kV, and they are all energized, de-energized or energized only as a residual energy after the whole thing has been disconnected. So maximum you can have in one bank of capacitor or in parallel capacitors is 60 kV. When they're when they are fully loaded, everything is grounded, as I say. So this bank of capacitor is grounded whenever it's not used. The same happens to the chamber. The chamber is also grounded by this strap below. Every grounding strap is marked by specific colored tape, green and yellow. Everything that matters is colored red. As I'm saying, this rod, this bit here, due to the fact that one can scratch his head. The same with the window and that handle. It's just that otherwise it's not be visible in the darkness. So later on that's okay. This is a spark gap box. So in this spark gap box there are spark gaps. These are controlled by air. So the air inside, basically the air inside is the environment in which those spark gaps working. Sometimes the installations with Marx generators are also operating on nitrogen as a gas, but here we operate on air. That's why we ventilate these spark gaps from both sides. It's a forced ventilation, so from one side we have inflow and from the other side we have outflow. We still have to set it up, but just for understanding that it'll be done. The whole installation so far has been not certified, authorized by the inspector, so we cannot switch it on, but that is just a preliminary show. So if you, Oleg, can open that spark gap so to show what is inside, please. So inside this spark gap box we see spark gaps. Spark gap is this distance between these brass balls. Each distance has got certain millimeters. It's going from 50 kV here, distance that corresponds to 50 kV, up to here, which corresponds to 250 kV. Each millimeter is 3.3 kilovolts. So each time whenever the system attains certain voltage, the whole capacitor bank will bring in a certain amount of power to the spark gap, and then spark gap triggers corresponding to different gaps between the spark gaps. That's how it works. And you see holes here, and there. These are holes that will be attached to the duct, so we can evacuate nitrogen and ozone that will be occurring inside the spark gap box whenever the sparks will start triggering. Now we want to show how the chamber is made and how you assemble the chamber whenever you start using the equipment here. So the chamber consists of several parts. You have the low part of the chamber here, which is conical vessel with a rubber bottom. It's the low part of the chamber. The upper part of the chamber that tilts to any of the directions, to the left or to the right, and it's kept on a special holder there. The part of the chamber that's in between the two parts of the chamber, basically the middle part, the table, it's inside the table here, and there is a sieve which is in between these two parts of the chamber. This chamber is locked by these latches, left and right. From below there will be handles to do it, and also in the middle part of the chamber there is a hose that you can use to outflow every bit of water from the upper chamber. So now Oleg will set up the whole chamber as it's in its operational mode. There are two rubber gaskets that use one O-ring rubber gasket that is pulled underneath the lower chamber. You pull it inside. The upper flange of the lower part of the chamber conical vessel has got a place for another rubber gasket, and then on the rubber gasket too you can place any of the sieves that you can use. There are plenty of the sieves. There are how many? 1, 2, 3, 4 and 5. There are 5 sieves, all the different diameters and different shapes that they can be used according to a specific range of crystals that you would like to be liberated from the host rod, that whatever the sample you will be treating in. Okay, now he is closing the chamber. It's pretty easy. There is the special linear here, and basically it's all in parallel now. He closes the chamber with the latches from both sides. Now the chamber is closed. You can pour water inside. So there is a little bit less than 90 liters of water that will fill the whole volume of this chamber, the upper part and the lower part. It can be less, it can be more. That depends on the amount of sample, according to Archimedes law. Then he takes the electrode and places it into the chamber and fix the lid by 2 screws. Anyway, so as we said, there is high voltage wire on the top, so it's pretty much fixed all the time. However, the gap between the insulation of the electrode and the electrode itself should be minimal. The distance between the electrode and the sieve should be maximum 25 millimeters, not more. No matter if the electrode touches the rock or not, it still be efficient, because our goal is to have those spark gaps hitting the rock and going through the rock to that sieve. The sieve is grounded, as we have seen the strap down there grounding the chamber. It's actually grounding the sieve. So everything that goes through the sieve after disaggregation goes to the lower part of the chamber below the actual spark and discharge, so it's not getting affected by any pressure or any other effect. So anyway, that's how the chamber works. Can you disassemble it again? Now he will disassemble it. Let's pretend that we have stones inside. So there are two ways to fill the chamber. You can put the stones first, or you can pull the water first and then put the stones. In this situation, we still have certain design of the chamber, so it can be changed. First of all, due to the fact that there will be water on the surface, we can reject the water each time, or we can take samples from the water, or we can drill a hole here and put a flange so to reject water from below, because the whole volume will be filled with water. It still be decided upon our experiments. There can be also the possibility to cut the fiberglass here. By the way, I forgot to say that all yellow materials are fiberglass, high voltage rated fiberglass. So you can cut through here and pull the stones through here. That depends on the situation. We kept this as a lid without any defect, because we want to know, in terms of the security, whatever, maybe people want to seal this here to be sure that nobody have access to the chamber with material inside. So this chamber is used in different ways. One of the way is to fill it totally with stone once you have the electrode on top, and then you have to have a window in that lid so to pour the chamber with the stones. Or you can basically treat different lumps of stones one by one, so to be sure that each one is disaggregating by itself, and control, for example, the large crystals that's facing up, and you want to be sure that you stop in the very moment that it starts loosening the whole sample, so you can take that crystal out of the matrix. So that will be also judged upon the primary rock that will be treated by EPD, and the sieve size that and shapes that would be used for different processes. So we want to discuss safety issues here. Well, first of all, there are safety signs that will have to be implemented according to local electrical code. That will be done later, so for now we will just imagine that these are. First of all, this means basically electrical basically electrical are on, okay? It's electrical inside, whatever. So because it's high voltage nature, that equipment must have some other signs, so we wait until the electrical inspector approves and let us know whichever signs will be here. So first electrical issue is the electric rug. Whenever somebody is operating, the device should stand on a dielectrical rug. That's to do with every code in every country. Secondly, every operator has to be approved to operate, so it will have to pass some exams of risk assessment of different procedures. That's to do with operation of this device. As I said, there are two systems that controls the safety. The first system is that window. Basically, through that window, it's pretty much obvious that we can control the operation of the device. There are few issues that can come up. First thing, if any failure, one can see inside. If the active bleeder is down, it means that all the capacitor has been discharged automatically. So whenever it's down, you can go inside the compartment. It can go down by itself in the situation of any failure, or it can go down whenever you switch off the device by the button stop, or it can go down by the emergency switch. It can also go down whenever you open the door, because you have the end switch on the side, which deactivates the system, and so the active bleeder goes down. It can go down whenever there is a failure of the capacitors or the power supply. In other words, it can go down at any time whenever you have problems with the device. There is another manual control of safety control of safety issue is this rod. This rod will be implemented each time whenever person wants to work with the chamber. The chamber is the only place where unauthorized personnel, whoever they will be using the device, can have access inside the compartment. However, before doing that, they have to take the hand rod in their hands, because it's always on the way of the operator, and the operator cannot miss it whenever it comes into the compartment. It has to hold it on the hand before the actual measure, and then he has to touch every part of the capacitor bank, which means that the contacts below of every stage of the capacitor should be touched. In other words, it should be grounded. If you can see, there is a strap going to the grounding from below and from above, all 5 stages. This should be done before entering into compartment at all times. Then it should be placed on the active bleeder like this, so that it doesn't, even the compartment will be closed and the person will be inside. There will be no way from the person outside to energize the system. So also this hand rod also prevents any unauthorized personnel to step down to other parts of the and basically mess with other parts that have high voltage nature inside the cage. The only place that the operator can do its own work, it's this chamber. That's enough space here to do that. Okay. This way you see the situation whenever anybody can enter the compartment with any level of authorization, because the hand rod is placed on the active bleeder, and any operator is safe inside the compartment because everything has been grounded to earth, and you can easily work with the chamber, whether you fill this with stones or fill it with water or anything. So every now and then one has to change the capacitors. That definitely should be an electrician. So whenever any failure with the capacitors happens, you will have the device in the failure mode. That will be the red light here, and you will basically see that the active bleeder will come down. In this same situation, the electrician will take the hand rod and change its ending, which is hook, to the part which looking like spear. So this electrician will put this inside here, and whenever he wants to change the capacitance, he has to visualize basically which capacitors got broken. He will have to take that spear and basically manually cut through this capacitor, just to be sure that it has been grounded completely. In this situation, whenever one would use that spear, there might be also the water basin here, just in case that you want to discharge all the capacitor completely in the water. In the manual for an electrician to change the capacitors, there will be a section with special photographs of the capacitance being broken, so he will recognize it by appearance. Usually capacitors that have been broken, they become a little bit darker than the others, and sometimes you will have the detachment from here or from there, from below, so you will visualize it pretty easily. Whenever failure happens, the first thing is to go around the bank of capacitors from every side and see if the failure happens due to the capacitors or anything else. The capacitors are connected by the washer here and by the washer there, so basically you have to detach it from below and from above. First of all, you shouldn't put any weight on the capacitors whenever you unscrew this capacitor from the copper contacts. Supply 4 capacitors spare, so they can be changed at any time. Supply spare coils, so whenever there is any failure due to coils and they can burn due to problem with varnish or whatever, they can also be detached by any mechanical activity, so you have to change these coils. These are 4. There are another 2 coils that can be used for replacement. So there are different levels of authorization. The first level of authorization is the level for electricians. Electricians should be authorized to work with the voltage higher than 1 kilovolt or 10,000 volts or 1,000 volts. Different countries, different level. So these electricians must be authorized to work with the device, not just as the second person, but also be involved in communication with the company producer of this device to report in terms of failure or any problems with the device. These guys really have to know the schematics, electrical schematics, and everything to do with the technical specs of this installation. They basically have to answer all these questions from the operators, as well as they have to perform exams for these operators, and they will have to undersign, or the operator have to undersign on the special form whenever it will pass special risk assessment, and the electrician that has got to do this first grade has to approve. It can be done each morning before the operation, it can be done weekly, but definitely due to the fact that the first grade of authorization, who are the electricians, they are responsible for the whole thing, they will have to advise upon the way, or they want to basically ask each day or every week or every now and then if the operator, in case of break, can forget of the procedure of operating the device. Okay? So there will be special lists of operation placed on the side of the machine, so everybody knows the order. There will also be a menu here, or the logbook that one would really sign for each day whenever they would like to operate the device. Anything happen, any failure will also have to be recorded. What the first grade of authorization will be led to. So first of all, it's controlling the operation by different other people. Secondly, is changing the capacity. Sometimes the only thing in this installation can got affected, can got changed by the electrician. These capacitors have a certain amount of time, or a certain amount of duration of pulses, or amounts of pulses. So every now and then they got exposed, or in other words, they got loose. So we have to change the capacitors. So the electrician can do that. We have special capacitors, spare capacitors to do that. So this part will be for electricians.